My dear students, welcome to Easy BTech, your guide for BTech and beyond. In this session, we are going to do problems on signal approximation. And before going to discussion of problems or solving problems, all of you share the channel. It is very helpful to you. So please share the channel. Let's start our session. Today's session. So first problem we are going to discuss is given a rectangular function. The problem is consider a rectangular function. Consider rectangular function which is equal to, this rectangular function is like a 0 to pi by 2 minus a pi by 2 to 3 pi by 2. This is minus a from pi by 2 to 3 pi by 2, and again plus a from 3 pi by 2 to 2 pi. So this is a rectangular function. Now the question is approximate above function, approximate above signal or function, above function using a cos t over the interval 0 to 2 pi. The interval is 0 to 2 pi. So this is the question he given. Let's see the solution, how to do. So here we have two signals. One is a rectangular function, another is a cos t function or sinusoidal function. So this rectangular function I am taking as x1 of t, the first signal x1 of t. This cos function or cos t I am taking as x2 of t. Now x1 of t in terms of x2 of t we need to express, we need to write. So what is the way of writing? Already we know that x1 of t is equal to, this is the way of writing, x2 of t c12 plus error xc of t. So this error signal is minimum, this error must be minimum. That is why this x1 of t will become or approximately is equal to c12 x2 of t. Okay, this is the way of writing x1 in terms of x2. So here the thing is calculation of c12. This is the important. How to calculate c12. So we know c12 formula. Already we know that. So we know c12 is equal to, what is the formula? Integral t1 to t2 x1 of t into x2 of t dt by integral again t1 to t2 x2 square of t dt. So this is the calculation of c12. This we need to do. That's all. Here x1 is having three values, three amplitudes, a, minus a, again a. Here as per 0 to pi by 2 it is a, pi by 2 to 3 pi by 2 it is minus a, 3 pi by 2 to 2 pi it is a. So according to that rectangular function or x1 of t, we have to split the integral. So that we will see now. So c12 is equal to, the first one 0 to pi by 2. What is x1? A. And what is x2? A cos t. So it will become a into a square cos t dt. Plus again pi by 2 to 3 pi by 2. Pi by 2 to 3 pi by 2. What is x1? Minus a. And what is x2? A cos t. So it will become minus a square cos t. Just following. And similarly 3 pi by 2 to 2 pi. What is x1? A. x2 is a cos t. So it will become a square cos t dt. So this is the numerator integral. And in the denominator we have t1 to t2, that is 0 to 2 pi x2 square means a square cos square t dt. So we need to simplify every integral, then we get the C12. So if you take first integral a square cos t, so what happens? Integration of cos t sin t, and the limits are 0 to pi by 2. So here plus into minus minus, again a square cos integration sin t, in limits are pi by 2 to 3 pi by 2. Here again a square cos t integration is sin t, limits are 3 pi by 2 to 2 pi, whole divided by, here we have cos square t. So cos square theta, like it is like, so we can write as 1 plus cos 2 theta by 2. So a square by 2 and integration 0 to 2 pi, 0 to 2 pi, 1 plus cos 2t dt. So now this sin t limits pi by 2, lower limit 0. So what we get? So here we have a square, a square, a square. We can take a square common. Okay, we can see later. That we can see later. So first one, sin pi by 2 minus sin 0. So it is sin pi by 2 1, 1 minus 0. And the second one, a square sin 3 pi by 2. Sin 3 pi by 2 how much? Minus 1. And sin pi by 2 1. So it is a lower limit, that is by minus 1. Next third one, again a square sin 2 pi 0 and sin 3 pi by 2 minus 1, minus minus it will become plus 1 divided by, so here a square by 2. So 1 integration t cos 2t integration sin 2t by 2. So here limits 0 to 2 pi, 0 to 2 pi. Now solving this a square. So here minus minus, minus 1 minus 1 minus 2 minus plus 2. So 2a square, again a square divided by, here we have a square by 2. Substitution of limits, 2 pi minus 0, 2 pi. Sin 2t, here t is equal to pi, so sin 4 pi. Sin 4 pi is 0 and lower limit sin 0, 0. So this term is 0. Now 4a square by, here 2 get cancelled, a square pi. So again a square cancelled, it will be 4 by pi. So this is the value of C12. How much we got? 4 by pi. Now the final answer we are going to write. What is the final answer is? x1 of t is equal or approximately equal to C12. C12 value how much we got? 4 by pi x2 of t. So this is the way of approximating x1 in terms of x2. I think clear it is. Go to the next problem. So he given a set of functions. He given set of functions 1 e power plus or minus j omega naught t, comma e power plus or minus 2j omega naught t, and so on. So he given exponential functions e power j omega naught t, e power 2j omega naught t, 3j omega naught t, and so on. So this is a set of exponential functions. Now prove, this is a problem, prove this set is, prove that the given set is, the given set is orthogonal, given set is mutually orthogonal over the interval, over the interval, over the interval 0 to t or t naught, over the interval 0 to t naught. Or we can write, sometimes they are giving interval like t naught plus 2 pi by omega naught. So if we given the problem, the interval is like this, you take t naught is 0 for simplicity, t naught is 0, then 0, 0 plus 2 pi by omega, 2 pi by omega naught is t naught again. Okay, just to take t naught is equal to 0 for simplicity, for simply doing this problem. So how to prove this, the given set is mutually orthogonal or not? First of all, the given set is a complex functions. We have complex signals, e power g omega naught t, e power 2 g omega naught t, complex functions they are. Okay. So for complex functions, what is the condition for orthogonality? How can we prove orthogonal or not? And he given set of functions. Set of functions. How can we prove it? The same, we need to calculate the integral, this integral t1 to t2, t1 to t2, the first function x1 of t, the second function x2 star of t dt. This integral value, if it is 0, then x1 and x2 are orthogonal functions. x1 and x2 are orthogonal functions. So here we have set of functions. That is why just modification I am doing. The simple modification is t1 to t2. This x1 I am writing as xm of t. x2 I am taking as xn. So conjugation is as it is, xn of t dt. So because we have not only two signals, here we have some m functions, n functions, set of functions we have. So in this manner, we should do the integral. Then if this integral is 0, then we can say the given set is mutually orthogonal over the interval 0 to t naught. So that is a way of doing. Let's start the solution. So integral t1 to t2 x m of t x n star of t dt, it is equal to 0. So here what is xm of t? What is xm of t? E power j m omega naught t. That is xm of t. Suppose if you take m is equal to 1, e power j omega naught t, first function, or it will become one function, one signal. 2 e power j 2 omega naught t. And what is xn? Xn of t? E power j n omega naught t. Right? What is x star here? Complex conjugation of n xn of t, that is x star. So it will become e power plus j, here we have, it will become minus j n omega naught t. This is x star, xn star t. So after knowing these two, we go for integration. So here integration limits is given 0 to t naught, and e power j m omega naught t into e to the power minus j n omega naught t dt. So here bases are same, both are exponentials, so we go for adding power 0 to t naught, and in the power we can take common j common, omega naught t common, so we get m minus n omega naught t dt. So if you perform this integration of e power j theta like or e power ax like it is, so same function we get e to the power j m minus n omega naught t divided by m minus n omega naught and j also, because we are doing integration with respect to t. So limits we have 0 to, limits are 0 to t naught, 0 to t naught. Now substitute upper and lower limits. So upper limit we have t naught, so j m minus n omega naught t naught, and lower limit is 0, so e power 0 is 1, that we can write later, divided by j m minus n omega naught. So here m n, they are integers like 1 2 3 and so on. I am taking the case m is not equal to n, m is not equal to n, like m may be 3, n may be 2, m may be 5, n may be 3, like that. M and n are not equal. In that case m minus n, it will become an integer, right or not? 3 minus 2 it will become 1, 5 minus 3 it will become 2, integer it will become. And here next thing is we have a relation between omega naught and t naught. What is omega naught t naught will become? Actually omega naught equal to 2 pi by t naught. So omega naught t naught will become this product 2 pi. Right or not? This product is 2 pi. Omega naught t naught is 2 pi. So in the place of omega naught t naught, we can take 2 pi. And in the place of m minus n, this m minus n will become an integer. Like maybe 2 or 3 or 4. So e power j m minus n is integer, again 2 pi. So this total value, here I am writing, e power j m minus n 2 pi. This total is always 1, because it is like e power j theta. According to Euler's, what is e power j theta? Cos theta plus j sin theta. So here theta is a integer multiple of 2 pi, right or not? Integer multiple of 2 pi. Theta is. Here also theta is integer multiple of 2 pi. So cos function will give you 1 and sin function will give you 0. So 1 plus 0 is 1. So this value is becoming 1 minus e power 0. What is e power 0? 1. So 1 minus 1 by j m minus n omega naught. So what is the answer? 1 minus 1, 0. 0 by something is 0. So this is the answer. We got 0. Right? So what is the conclusion? What is the final answer is, the given set, what is the set here? 1 e power plus or minus j omega naught t, e power plus or minus j 2 omega naught t, and so on, is mutually orthogonal. Mutually orthogonal over the interval 0 to 2 pi, 0 to 2 pi for m is not equal to n. This is the conclusion. M is not equal to n. Okay. So in this session we have discussed 2 problems. Still we have some more problems, we can have discussion. So all of you please watch, subscribe the channel. Thank you. Thank you all.